Okay, welcome. This is some advanced electron configuration practice. So let's get out our large periodic table in the back in the honors section with the advanced electron configuration notation. All right, here we go. Which term is defined as the region in an atom where an electron is most likely to be located? Well, that's an orbital, the region of most probable location. Which orbital notation represents a noble gas in the ground state? So remember, noble gases, this is group 18. And group 18 noble gases have full outer shells, but in this case we go full orbitals. Full outer orbitals. So 1s2, there's only one orbital and it's full, so maybe that's it. And just for kicks, I'm going to look that up. That's helium. 1s2, 2s2. Well, it's not a full outer orbital because there's a 2p that's not there. 1s2, 2s2, that is beryllium. And that's not in group 18. A is. 1s2, I can obviously see that this is not filled. So that's 2, 4, and 3. So that's 7. Yeah, that's nitrogen. And this is not filled. Even though this is not filled, which means it's not in the ground state, so we don't want that. So it is choice A. Base your answer on the following question on the orbital notation of an atom in the ground state. Which atom is represented by this? Well, I think we just talked about it. 1, 2, 3, 4 electrons. So it's in the ground state, so 1s2, 2s2, that's beryllium. That's choice D. Which atom in the ground state has 3 half-filled orbitals? Let's go down here. So phosphorus has 15 electrons. So 1s2, 2s2, 2p6. So there's 10. Whoops. Yeah, 3s2, 11, 12, 13, 14, 15. That looks like it's probably our answer, but let's just keep going. Silicon is 1 less than that, so not that. And then aluminum is 13, so that's not going to do it. Yeah, I'm going to go with this. What is the total number of unpaired electrons in an atom of oxygen in the ground state? So let me erase that. Oxygen is 8 electrons, 1s2, 2s2, 2p. So 1, 2, 3, 4, 5, 6, 7, 8. So how many unpaired electrons are there? 2. Boron in the ground state. So boron has 5 electrons, so this is not ground state because we didn't fill that first one. And this is not ground state. Oh, and look, this is not ground state. You have to fill them up, the Aufbau principle. Fill them up from the bottom first. So choice B. Which electron notation in the valence electron of phosphorus in the ground state? So get rid of that because that's not ground state. Phosphorus has 15 electrons. Oh, we just drew this and I erased it. But it's just valence, which means the outermost. So phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. So we only care about the valence 3s2, 3p3. So s2 and 3. Now, they all have 3, but the only one that fills following Hund's rule is B. 1 at a time, then you double up. This wouldn't work and this wouldn't work. The outermost, so that's the valence of oxygen. So oxygen is 1s2, 2s2, 2p4. So this is our valence. So we have 4 electrons. Follow Hund's rule. You'd have 1, 2, 3, and then a double up. So, this one has 2 up arrows. That's really sneaky. You want that because you have to have that opposite spin. The orbital valence is the outermost. So who would this be? This would be lithium. Lithium is, well, let's see, 1s2, 2s1. So nope. Silicon, let's see, 1s2, 2s2, 2p6, 3s2, 3p2. Ooh, silicon. That looks like that's our answer. Aluminum is one less, so that wouldn't work, and chlorine is more. So yeah, it is silicon. Finally, the last one, let me erase this. What is the total number of partially occupied 2p orbitals in a nitrogen atom in the ground state? So nitrogen, 1s2, 2s2, 2p3. So if I'm drawing this, the 2p, 1, 2, 3. What is the total number of partially occupied? They're all partially occupied, so choice C. If you have any questions, please let me know. Thank you.